everyone, I'm Ayush. Today I'm going to talk about graph neural networks or GNNs, a fascinating architecture that lets AI understand not just individual data points but the relationships between them. Think of this as giving AI the ability to see connections, not just isolated dots. Why traditional neural networks fall short? Traditional neural networks like CNNs and RNNs work beautifully on grid like data. For example, images where pixels are arranged in rows and columns, or text where words come in a sequence. But the real world data is rarely arranged like grids. Most data is interconnected. People connected on social networks, web pages linked together, atoms joined in a molecule, or cities connected by roads. If we look at individual data points without their connections, we miss the bigger picture. Think of it like social media. Imagine trying to understand someone just by looking at their profile photo. You wouldn't know their hobbies, friends, or the communities they are part of. GNNs are like being able to see their entire social network, who they talk to, who they follow, what groups they're in, and using that to understand them in context. What makes graphs special? Graphs have two main parts. Nodes. These are entities like people, atoms, or web pages. Edges. These are the connections between them, like friendships, chemical bonds, or hyperlinks. This network structure gives a rich context that traditional methods can't capture. How GNNs learn? Message passing. Each node collects information from its neighbors, like gossip spreading to friends. Aggregation. The node mixes what it heard from others with its own features. Update. It updates its understanding of itself. Iteration. This repeats for several rounds, so information slowly travels across the whole graph. By the end, each node knows not just about itself, but about its whole neighborhood. Real world applications. GNNs are making real impact in many areas. Drug discovery by analyzing how atoms in molecules are connected. Recommendation systems like Netflix, Spotify, which consider social and content relationships. Fraud detection by spotting suspicious patterns in transaction networks. A concrete example would be molecular properties. Let's make this concrete. Say you want to predict if a molecule is toxic. A traditional model might just look at individual atoms, but toxicity may depend on how these atoms are connected. The same atoms arranged differently could be a medicine or a poison. GNNs can spot these structural patterns, for example, certain ring shapes near specific groups, and learn what makes a molecule dangerous. The power of neighborhood context. Each node starts with its own information, then it learns from nearby neighbors. After several rounds, even faraway nodes influence each other. This creates a deep contextual understanding that captures both local details and global patterns. Why this matters now? Our world is becoming increasingly interconnected. Social media, supply chains, biological networks, and the hardest AI problems today aren't about isolated problems. They're about understanding relationships. GNNs give us a scalable way to do that. Key takeaways from this, to wrap up, would be GNNs go beyond traditional AI by understanding relational data. They learn through connections, passing information through nodes, and they've already have a real impact from drug discovery to fraud detection. In short, GNNs help AI see not just what things are, but how they are connected. Thank you for listening, and I hope you can see how connections can be just as important as the data itself.